All right, so good morning, everyone. Let's get started. Today, we are going to talk about Java. So this is our day one on Java. I just want to help you out to understand what exactly this Java is, how it can help you in your career, and how do we get started from there, okay? Now, Java is, if you see, Java is one of the very popular programming language, and that is ruling the market since last 25 years, okay? Now, I started Java when I was just 14 years old. Like I joined NIIT. You might be knowing NIIT and APTEC. So in India, so I joined a program, a one-year program, and I was in class 11. Okay, and from there I started learning Java. Okay, now somebody told me that, hey, if you learn Java, Java has a very great future, and tomorrow you would be able to make a lot of money out of it, probably. Again, he was not wrong. Right now, Java is used everywhere. Okay, so if you talk about any product-based companies, I really don't want to just talk about FANG. Okay, but if you talk about any good product-based companies, all banking companies, insurance companies, and every other company, you'll find a lot of companies are using are writing their main core services using Java. Okay, for example, if you are booking your ticket through IRCTC in India, it's all Java behind the scene. Okay. Now, I'm not saying that other technologies are not used, but what I'm trying to tell you is, whenever there is a need to write core services of a company, most likely companies are preferring JVM based language. Okay. And in the JVM based language, Java is something which is still topping the table altogether. So you have to be very clear why exactly we are learning Java. We are learning Java because at the end of the day, once you are done with this program, you should call yourself as an expert in core Java. Okay, I will try my best to teach you every possible stuff so that Java is very easy. Now, a common problem we have seen people are talking about is Java is very hard. It's actually not hard. It actually depends on who is teaching you, how he is teaching you, and how much practice you are doing altogether. Right now, at the end of this course, I'll give you a guarantee. You follow me completely and I'll make you a Java champion. Okay, so let's get started, guys. Now, so in every session, what we'll do is we have our own agenda, we have our notes. We'll just go through the notes as well so that we don't miss anything out. Okay, so let me share my screen and I'll share the notes, and we'll go along with the notes all together. Now, before we start, what I would like to show you is, every time I start a new language, I basically try my best to tell you the main guy behind that technology. Okay, now he is Sir James Gosling, who is actually the creator of Java. Right now, let's understand what exactly Java is, how they are categorized all together, and then we'll take it forward. Okay, now whenever somebody talks about Java, you need to understand that Java is a programming language, number one. And you need to understand that Java are categorized into multiple parts. Okay, now what are those parts? Those parts are basically three. Okay, so there are three core part of Java. When somebody talks about Java, then either it is J2SE, or it is J2EE, or it is J2ME. Okay, now J2SE stands for Java 2 Standard Edition. Okay, J2EE stands for Java 2 Enterprise Edition, and J2ME stands for Java 2 Micro Editions. Okay, so these are the three popular categories of Java. What are we trying to focus today in this lecture, right, or in this whole training program, is all J2SE. We are going to talk about Java Standard Edition. That is, we call it core Java, right, but then it is actually J2SE. Okay, now J2SE can be used to build a normal programs, okay, a CUI based programs, a GUI based programs. Okay, and it has all the basic fundamental set of libraries and APIs. What is API? We'll talk about that. Okay, now you can build either a GUI based applications. For example, I want to build a simple calculator, the one which looks like a Windows. Can I do that? Yes, you can. Okay, Java has certain classes and libraries which can help you to create those kind of applications. I want to just create a like a command line interface applications. For example, take two numbers from the user and then add it and then give me the output of the sum. Can I do that without using GUI? Yes, you can. Okay, so they are called as CUI, character user interface. And whenever you see graphics, that is called as your graphical user interface. Okay, now when we talk about J2SE, J2SE also comes with a lot of facilities or lot of libraries. Like you want to talk to the database, the best way would be a JDBC, and JDBC is a part of your core Java itself, J2SE itself. Okay, so you can also do a database connectivity using JDBCs. You can call some remote method, like for example, let's assume you have two different machines altogether, and in machine one you have activated some Java code, and from machine 2 you would like to call that Java code, a remote method invocation. That can also be done. Okay, and it has a lot of collection classes. You can store a lot of data in collections, list, set, map, and so on. So we'll be figuring it out, all those things, as we encounter them. Okay, so today it's just a high level understanding on the Java itself. Okay, now J2EE, if we talk about J2EE, is for enterprises, right? For example, I want to build a website. What should I do, right? Do I have something in Java? Yes, we have. Okay, so your J2EE provides you something called servlets and JSPs, which is actually the core backbone of your Java-based web applications. But these days, a lot of third-party libraries like Spring are actually used. Okay, now people are not using servlets and JSPs directly now, but they are internally. And if I talk about Spring has a module called Spring MVC, which is actually based out of your servlets and JSP. Okay, so that's how the Java is still used in if you're writing a Spring Boot applications or so on. Your J2EE is still used internally. Okay, so you can either build the applications by using servlets, JSP, EJBs, or you can use a third party, as I said, like Spring, Hibernate, and so on. They are all called as framework, which is actually built on top of your Java programming language. Okay, now J2ME is used for building some micro level applications. For example, I want to build some applications for my mobile, or I want to build little tiny applications for probably my remote, right? So in those cases, you can use J2ME concepts. Okay, now, but then today, because of Android and all, like most of the mobile based applications are all built in like using Androids and all, right? So that's how we can basically categorize Java into 3 parts, right? So if somebody talks about Java, so either it is J2SE, or it is J2ME, or it is J2EE. Okay, J2SE is also popularly called as write once, run anywhere. Okay, this is the biggest advantage of Java. For example, when you write a Java program, it can run on any platform. That's the beauty of it. Okay, and I'll talk about this, how exactly this is made. Okay, I'll talk about this in some time. Similarly, J2EE, the main agenda of J2EE is write once and deploy anywhere. Okay, so you write the code, you build the jar or var, especially var files, and then deploy that on any server or on any platform. You don't really have to make any code changes. Now, some fun fact about Java. Let's understand this. So according to Oracle, Java technology is used by more than 6 million developers, and it runs on more than 5.5 billion devices. Now think about this, the use case of Java, right? Java is used by every top product based companies to build their core product. This is what I want to highlight. I have worked in so many companies, and mostly I have worked on JVM based platforms, JVM based languages, and you'll find Java everywhere. Okay, now if you talk about companies like Cisco, Flipkart, Amazon, Apple, Walmart, Qualcomm, Adobe, Teradata, and whatnot, you'll find Java everywhere. Okay, so Java is something which you really don't have to worry what will happen tomorrow. Okay, in fact, let me be very honest, sometimes people are not able to find Python little scalable or stable, and because of that they are moving back to Java to build only that core part. Rest of the things can be managed by any programming language, but that's the beauty of Java. I'm not telling it. People who are actually working in the industry on AI applications, they told me this. Okay, now before we move further, let us try to understand how this Java started. Okay, because it's very important for us to understand the history of it, like what happened, like what made what made James Gosling to invent this Java, right? So the history goes something like this. In June 1991, okay, people like James Gosling, Mike Sheridan, Patrick Naughton, okay, initiated the Java language project. In 1991, they started this project, and initially this project was called as the Green Project, And these people were the core part of this green project, and they were called as the green team. Okay. Now, the programming language was designed for small embedded system in electronic appliances. Think about this. In 1991, I was just 2 years old. That time, these guys were actually trying to build some language that can be used for embedded systems altogether. Initially, the language was called as Green Talk. Why? Because the team were called as Green Team. Okay. Now, because of that, they thought, okay, we talk a lot, we build something, and let's call this project as a Green Talk. Okay. And the extension of that file used to be .gt. The extension of the file used to be .gt, Green Talk. Okay. And then what happened? Later, these guys actually renamed this to Oak. Okay, it was renamed to Oak. And why did they give the name Oak? You know, because it is believed that oak is a tree. Okay, just Google it out. Oak is a tree, and it is believed that oak is very, very strong, and because of which the tree oak is represented as a national tree in so many countries. And they felt that whatever they're building is very strong, because nobody would call their product weak, right? So that's the reason they thought, okay, let us give a name called Oak. Okay, and then they gave the name of this language is Oak, but they had to rename it to Java in 1995. Why? Because there was a company called Oak Technology who had already taken the copyrights of this word OAK. Okay, and because of this copyright class, the project Oak is now renamed to Java. In January 27, 2010, Oracle announced that it has completely taken over Sun Microsystem. So Java was initially the product, the language built at Sun Microsystem, but in 2010, Oracle took over Sun Microsystem, and now Java is a part of Oracle itself. Okay, so this was a very small history about Java. It's very important to know how the language has actually come to the market altogether. Okay, now why the name was given Java? Okay, so Java is, if you see, Java is basically an island in Indonesia. Okay, where first coffee were produced, and probably, you know, we all are very fond of tea and coffee, the software developers, right? Probably this green team was consuming a lot of coffee, probably. Okay, and that's the way they felt, okay, we owe this entire programming language to coffee, so let's name it something like coffee. And then they thought, let's give the name Java, because Java is a popular place in Indonesia where a lot of coffees are produced. Okay, and that's how the name was given as Java. Okay, so the entire green team probably loved coffee, and hence the name Java. Okay, that could be the reason. So that's how actually the whole Java came into the market. It started as a small language for embedded system, and gradually it became a big project. And today, as I said, the whole industry is using Java. You may say, okay, that's great, but can you tell me some of the products which are basically built on Java? What are the products which are built on Java? Okay, now I've just given some names, but these are not limited. There are so many. Okay, now let me tell you one thing. Today, if you look into the industry, one of the top technology that pays really well is data engineering, right? And when I say data engineering is all about big data, Hadoop, Spark, Scala, Kafka, Elasticsearch, and whatnot. Okay, now most of those frameworks or tools are all built in Java. That's the beauty of it. See here, Apache Hadoop, Apache Hive, Apache HBase, Apache Kafka. I did not write a lot of stuff, but then there are so many products which are built in Java. Okay, Elasticsearch, Neo4j, Jenkins, Apache Maven, JMeter, Kubefs, and so on. So there are so many products which are built in Java. If you want to know more, then I can also help you out. What you can do is just go to here and just say Apache dist. Okay, just say Apache dist, and you'll find a directory which contains a lot of Apache products. These are all Apache products. Okay, and most of these products are written in Java. Not all, but most of this. Okay, so just scroll it down, and there are so many products. There are so many products, right? And all these products most likely are written in Java. Most likely. Okay, so that is how, if you see, the whole industry is using Java in one or other way. And they are very popular in building tools, the product. Because the product, once you build, you really don't want to scrap that away, because building a product takes a lot of money, right? A lot of time. And you really don't want to experiment it. And the biggest advantage now is Java has already proved itself on creating very, very large distributed applications, because of which, if there is a need to build something very big at an enterprise level, people are not even thinking of any other programming language, because they know that Java has already proved. They don't want to take risk probably. Okay, now that's what it is. Okay, now let's talk about the version release of Java, like which version came when it started, what the current version right now, and so on. Okay, so in 1995, Sun Microsystem officially announced the first version of Java, and we used to call it JDK alpha beta version in 1995. And then it started like this: 1.0 was on 96, 1.1 was on 97, 1.2 was on 1998. This is the version which I studied in 2005. This is the version which I studied in 2005, JDK 1.2. When I started my computer programming course in 2005. That time, probably if you see, Java 5 was already there, right? But then that was not the industry standard. That time the industry standard was probably 1.2. Okay. Now, then 1.34. Then if you see, after 1.4, they stopped calling it 1.1, 1.2, 1.3, 1.4. And what they did is they started giving the name like 5.0, 6, 7, 8, 9, and so on. They changed the number, right? And if you see the Java 6 onwards, they dropped this name called 2. And what they did is this started calling it JSE. Okay. And then onwards, it is JSE 6, JSE 7, JSE 8, and so on. So these days, people do not call it J2SE, people call it JSE. With the version is not 1.1, 1.2. The version is 6, 7, 8, 9, and so on. Okay. So likewise, if you see, this is how the whole release dates are all about. Okay. Now, currently, if you see, we have the recent version is this Java 18. Let me just cross check this out. Java latest version. Okay, so it looks like the Java latest version is Java 18. Okay, Java 18. And these are all the planned release date. It may go here and there and so on. But if you see, currently the recent version is Java SE 18. And that's how they are actually releasing the versions. If you look into this whole information, then you can see that they are actually releasing the version every September and March. Okay, now it is August, probably next month they will release another version, right? And if they are releasing another version, and if we see any new feature which is to be considered, we'll also cover that. Okay, so that's how, you know, like the whole hierarchy of Java versioning started, and today the recent version is Java 18 altogether. Okay, now you may ask me, okay, that's fine, but can you tell me what is the popular version which industry is using? Okay, so industry is using Java 8 very actively. Java 8 is still popular. There are few companies who have moved to Java 11. Okay, there are few companies who have migrated to Java 11. But if you ask me what is the most popularly used version today in industry, it's Java 8. If you're good at Java 8, you are good to go. You don't really have to master everything of Java 11, 12, 13, 14, 15 and all. Okay. But then see, like in all these releases, what happens, you know, one or other important feature comes, one or other important bug fixes or gets released, right? And that's how it works all together. Okay. So industry is currently using Java 8 very, very actively. There are few companies who have moved to Java 11. And most of the startups, when they build the product, what they do, you know, they love to experiment with the newer version. So you should not be surprised if somebody says we are using Java 15. If it is a startup, they basically take that risk. If it's a big company, they would not take the risk. Okay, they would take a lot of time to implement it. Like as I said, like, you know, I studied JDK 1.2 in 2005, and if you see, legally in 2005, I would have studied Java 5, but that was just released. right? That was just released and that was not the de facto industry standard, probably, right? And that's what it is. Okay, so we'll go one by one. Number one, object oriented. 2, simple. 3, secure. 4, platform independent. 5th, robust. 6, portable. 7, architecture neutral. 8, dynamic. 9, interpreted. 10, high performance. 11, multi-threading, and 12, distributed. These are the 12 different reasons why you should learn Java. Okay, so these are all the features of Java, right? Now we would like to go ahead and let us try to explore all these features one by one. We'll go with the with number one, features of Java, object oriented. Now what does it mean? Okay, now object oriented means when you write a Java code, you will basically think about object, classes, interfaces, and so on. What is object and classes? We'll talk about that in great detail in the coming lectures, but let me give you a small hint about this. If I ask you to categorize you and me, you would probably call we all are human. Okay, you would not call men. The reason is because women are also attending the program, right? Right. So if you see, like the common thing between you and me are both of us are human, right? Now you have different property, I have different property. For example, I have a long hair. Okay, you do not have, right? So that's my property. I'm a human. And again, if you ask me my gender, I'm a male. And if you ask me my attribute, I have a long hair and I teach and I do something else and so on, right? So if you look into the common category, that's human. So you can call human a class, a blueprint, okay? And I'm one object of it. You are one object of it. That's how you should be basically able to like distinguish this. Let's go a little deep because I want you to understand the classes and object to itself little bit, not like at least on theory you should understand what are the classes and objects. Now let's take an example. Suppose you want to build a house. Okay, when you want to build a house, what you'll do, you'll basically go to the builder, right, or the architect, right? So the designer, the architect, and you'll say, sir, I want to build a house and my area is 2000 square feet. Okay, and I want to build a house. You give me some good plan, right? And what he will do, he will actually open some of the predefined plan, whatever he has already built for his customer, right? So because he's doing this business in so many days, so he would say, okay, I have a lot of beautiful plans. You just look into all these plans, and if required, we'll modify. Okay, if not required, we'll go ahead with the same, whatever. Okay, now he will show you some of the good plans, whatever he has created. And most likely you will love his plan, probably 80 to 90%. You may have your own custom requirement, I understand, but most likely you'll love his 80 to 90% plan because he has been doing this since so many years, right? So you will say, okay, there is plan A, there is plan A, there is plan B, and there is plan C. These are the 3 popular plans which I have built that can help you to construct a house of 2000 square feet. Okay, now you'll say, okay, I love this plan. Let me go ahead with this. I do not want to do any modification because this looks absolutely perfect, and I would like to go ahead with this plan. Okay. Now, when you choose this plan, does that mean you have built a house? No, right? You have just selected a plan out of it. And then what you need to do is you need to buy the land, or you have whatever land you have, and you need to start constructing the house, right? After you construct this house would be given some number, let's say house number 1, or let's say house number 101. Okay. Similarly, you build that house and I saw that, okay, this guy has built a house. Why can't I build a house, right? And I'll somehow figure it out. Where did you go and build the house, right? And maybe I'll go to the same builder and I'll say, dude, I also need a house. And this guy has built a very beautiful house. Can you also help me out? And he may also present me the same plan. Okay, probably. Okay. And then I'll say, okay, I also love the same house and same design. I also want to build the same house in the same style, right? So again, I'll start constructing it in my place. Okay. And hence I'll start building a construction. And after some months, I also have my house ready, and my house would be given a number, let's say house number 102. Right. Similarly, again, third person went to this builder and he says, hey, I would love to go ahead with this plan. Okay. He also constructs a house. Now, can I say here this A, B, C are just a plan? They are actually not house, right? When you buy this when you go to this when you go to this architect, what you get is you just get the layout, you just get the plan. That does not mean that you have constructed the house. You cannot sit on that plan, right? You cannot stay on that plan. It's not it. But by taking that plan, you have to implement it. Okay. So that is what you call a class and object. Okay. So a class is basically a prototype of blueprint, whereas an object is one instance of it. One instance means one real working model of it, right? So similarly, let us try to figure it out, some of the classes and object. Okay. Can I call a bike a class? Yes, no. I want you to answer. Can I call a bike a class? Yes, right? I can call a bike a class. Why? Because when I say bike, when somebody says I have a bike, what is the visual, representation that comes to your mind? Bike means one handle, right? And you have a gear systems, and you sit and you drive. When somebody says car, okay, car means like something which looks like a room wherein you can sit and drive. That's the visualization you get when somebody says bike or car. So can I say bike and car is a class? Yes. Okay, but it is not an object. What is an object? My bike is one object, right? Like I may have Pulsar and you may have Apache RTR. Okay, and you have purchased one version of it and it has got a serial number, right? Do you all agree with me that every bike that you purchase, they come with some engine number or chassis number or some sort of number, right? That is an object for you. Is not it? For example, when you bring your Pulsar, when I bring my Pulsar, both of these Pulsar are actually the object of same class. And what is that class? Pulsar. Pulsar is the class, but your Pulsar with serial number 1, 2, 3 and my Pulsar with serial number 4, 5, 6 are two different objects. So are we clear, guys, what is a class and what is an object? Now, for example, let's take another example. This is a marker. What do you call it? It is an object or it is a class? This is an object. The reason is because it's mine. It's not yours. You cannot buy it from me now. It's already taken. I acquire it. It's something physical which I can sense, I can feel, right? So this is object. If this is object, then what is the class? Can you tell me what is the class? Marker is a class, right? Marker is a class, and this particular marker, which may have some sort of number, probably it is there or not, it's not an issue, because if it is a local marker, then you may not get a number. But if you look into all international products, every thing will have a number, right? Now let's take another example. My MacBook, is that an object or a class? It's an object. What is the class then? Class could be a MacBook, right? It's a class, right? So now what you can say is computer can be a class, laptop can be a child of it, in that Mac is another class. Okay, and again Mac comes with what? Pro and Air and all, right? So they are also a class, but the laptop which I have is an object for me. Okay, so that is how you should basically visualize the object and class. Okay, now I want to ask you a question, like your house is an object or not? Your house is an object or class? It's an object. Your house is an object, is not it? So that's how you have to understand. Now if you look into the world, everything is object and classes. For example, you're driving it on the road, you have your own car, that is your object. You're driving on a road, that road is an object. Okay, and then you went to an airport, that airport is an object, because the airport of Hyderabad, the airport of 𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪 are all different. What is the common thing between them? They are airport. So if you ask me the common class between those airport, I would call it airport is a class. But this 𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪𝗪 with respect to object and classes. Okay, done. Next, simple. Java is simple, guys. Okay, so if somebody says Java is complicated, ask them to attend my classes. Okay, I'll make it simple for them. So why Java is simple? Because you do not have a concept of pointers. I remember when I was in BTech first year, pointer was very hard, and I'll be very honest, I found it very easy. The reason is I had spent a lot of time. Okay, but most of my classmates actually found it very, very hard. The reason it was not something very simple to master. Okay, so pointers, you do not have a concept of pointers in Java. Thank God, right? We are saved that you do not have a pointers here. Next, no operator overloading except plus symbol. So in C programming or C++, you'll see there is a concept of operator overloading where you can overload anything. And the biggest problem is you get confused. But in Java, it says except plus, I would not override anything. And that's the beauty of it. No operator overloading concept. Next is very simple to write provided you love it. See, any language is simple if you master it completely. Okay, but with just half knowledge, it's very hard to work with that. And that's the reason many people find it hard. But it's not hard. The reason is unless you don't learn it in a proper way, it is always hard. Okay. Next, Java is secured. How do you say that? Okay, because whenever you run a Java program, whether you run it locally or whether you run it on a server and all, Java runs on its own virtual machine called JVM. We call it Java Virtual Machine. And that is basically a separate entity altogether, which means when a program is running on a JVM, it does not allow you to access the system resources unless and until you don't give a permission to it. And that's the reason Java is called as secure. Okay, so Java has a concept of security manager and class loader, which actually helps you not to access anything which you are not supposed to. Okay, and as I said, Java runs inside a virtual machine. Next, platform independent. This is very, very important feature. So the biggest problem of C and C++ was what, I don't know how it is now, but earlier the biggest problem with C and C++ was they were platform dependent. Like for example, the behavior of integer, okay, in Windows, the behavior of integer in Linux were completely different. Like it was storing the same value, but the size was differing here and there. Okay, and Java said, hey, we really want to make sure that everything is stable. Okay, and hence the code what you write in one platform will run exactly same in another platform with no code changes. Let's talk about this a little bit. Java is platform independent. Let's understand what does it mean. Okay, so as a programmer, you will write a Java code. Okay, that Java code will have an extension .java. Okay, for example, when you save a text file, what is the extension of a text file, guys? .txt. Okay, when you listen to a music, what is the extension of that music file? MP3. When you watch any movie, what is the extension of that? Probably MP4. Similarly, when you write a Java code, you have to save it as .java. Okay, for example, let's say the file name is hello world. So you wrote a code in a notepad. We will learn it. Okay, and then you save that file as hello world.java. After that, you will compile it. Okay, you will compile it. What it produces, it produces .class file, right? So after compiling, this becomes hello world.class. Okay, and this is basically called as bytecode. This is basically called as bytecode. Okay, now let us take three machines all together. I'll say Windows. I have a Windows machine. I have a Linux machine, Ubuntu, and I have a Mac. Right now, if you want to install Java in all these machines, the Java softwares are different. For example, in Windows, you will get java.exe, right? You'll actually install your JDK. I'll say JDK. Let me say jdk.exe. And this is for Windows. Okay. Now, if you are working on Linux, most likely you will install JDK some version.zzz. All right. And if you're working with Mac, then most likely you'll install JDK some version.dmg. So these are the files, right? These are the executable files for all these machines. Now you will have to install Java on Windows. You'll have to install on Linux. You'll have to install on Mac, and all these Java softwares are different, right? The Java software that you need to install on Windows cannot run on Mac because the extension is completely different. But once this Java is installed, okay, once this Java is installed, what you get is you get compiler everywhere. You get compiler everywhere. Okay, So all these compilers are platform dependent. Understand this. The compilers are platform dependent, which means the compiler for Windows, the compiler for Linux, the compiler for Mac are different. They're not same, right? Because that's how, like, they're all different platform altogether. But once you compile your Java code, maybe here or maybe here or maybe here, what you get is you finally get a bytecode, a dot class file. Okay, a bytecode, a dot class file. And this dot class file now can run on any machines. Okay, so see, every platform will have two things, compiler and interpreter. Here also you'll get interpreter. Okay, here also you get interpreter. Okay, now the compilers are platform dependent. Interpreters are also platform dependent, but everybody can understand this dot class file. Okay, so this dot class file, whatever you have produced, if you have produced a dot class file in Windows, you can run this dot class file here as it is. Similarly, here as it is. Okay, that's how it works. Let me give you an example. So let's assume you went to a hotel, okay, and you wanted to have a Coke. You ordered a Coca-Cola or Pepsi, right? Now what you get is you get a product. Now tell me one thing, what is the difference in taste of a Pepsi that you consume in a local restaurant or a 5-star hotel or a mall? Do you agree with me that it's same? The taste is same unless and until somebody has not mixed anything, okay, right? So the taste is same, but if you see, the environments are different, right? So in good hotel, you may be consuming the same cold drink with a soft background music, okay, and in a local hotel you may be consuming the same cold drink with a lot of loud voices of the audience, right? So but if you look into the taste remains same, the environment is different. So what I'm trying to tell you is, when you are working on this Java, you write a class file, you write a source code, you compile it, and you get a dot class file. And this dot class file can be understood by any of the interpreter as it is without any change. Is that clear to everyone? So we talked about this. Okay. Now we'll talk about robust. Now robust means what? Okay, robust means it does not break. It is strong. It does not break so frequently. Okay, let's understand this. So Java has a concept of strong memory management using garbage collection. It helps you to make sure that the room is cleaned every now and then as much as possible. Okay, it has no pointers, so no access to outside object. Let me tell you, the biggest drawback of the pointer was what, once you acquire that pointer, you are actually allowed to access something outside of it, which was very, very risky altogether, and it may give you access to something which you are not supposed to. Okay, and hence Java does not have a concept of pointers. Next, it has an effective exception handling that helps you to prevent the crash. For example, if at all you feel that certain things are not valid, what you can do is you can use the concept of exception handling to handle your code. Your code should not throw you null pointer exception at the production, right? So very effective exception handling techniques to make sure that the code does not break. Next, most of the data types are platform independent. In C, size of int depends on the platform. If you have used C programming, then the size of integer used to be something 2 bytes on one machine, and the same integer used to be 4 bytes on another machine. Okay, but in Java that is not the case. Okay, so that makes the Java most robust. Robust means it is strong and it does not fail a lot. Okay, next, portable. So portable means the code, whatever you write, is portable to any other platform, right? For example, as I said, like the source code what you have built would be converted to dot class. Dot class are all byte codes, and these byte codes can be used in other platform as it is without any change. Okay, next, architecture neutral. What do you mean by that? If you look into a machine, right? So all our machines, whether it is a Windows machine or whether it is Mac or whether it is a Linux machines, whatever machines, right? If you see all these machines are built with certain processor, with certain architecture. Okay, the way your Intel works, the way your M1 works could be different. Is not it? So for example, I may buy a laptop with Intel i9 or i7. You may buy a M1 chip machine. Somebody else might buy AMD machines. But at the end of the day, they are all processor. But do you agree with me that these processor definitely are different? They are not same. The way it works would be completely different, right? But Java makes sure that even if it is whatever processor you are working with, the code that should give me this output will always give me the same output across all the platform, right? Otherwise, what will happen? You end up building different products for different environment, and that is what Java says. We really do not want that to happen. You build the code once, you write the code once, and we'll make sure that it is running on any platform as it is without any code changes. Okay. Some of the popular architecture are ARM, x64, x86. Just Google it out, you'll get a lot of information if you wish to, but it's not that much important for us, right? So the only thing that you need to understand is this concept, right? So the Java has a powerful feature wherein it says you build the code, you compile the code once, get that .class file, and then it does not matter where you run. Okay, I can support any platform, I can support any architecture machines altogether. Dynamic. So what do you mean by dynamic? Dynamic means it is not the same hard-coded static stuff. If you feel you want to create your own classes and object, you have your own customization to do, you can do it very easily in Java, as well as other programming language also supports that, right? So this discussion is not about how Java is better than anybody else. This discussion is all about what is the feature of Java, right? So in some of the features are also available in other programming languages. For example, dynamic, you can do the same thing with other programming languages as well, right? So allows you to create and extend your own classes. And Java has a concept called JNI, Java Native Interface, which allows you to call a code written in C program. So, okay, so for example, you may have a code or a library which is basically written in C. And probably that is something which you cannot replicate in Java because somebody has already done enough research and built a product using C. And what you would like to do is you would like to call that program from your Java. Is that possible? Yes, it is possible. For that, you need to use a technique called JNI. Okay. Next, interpreted. So as we discussed in the board, Java is an interpreted language. What does it mean? Let's understand. Okay. Now the Java compiler compiles the source code that is .java to a Java bytecode. So your .java is converted to .class, and that is done by your Java compiler. And as I said, whenever you install Java on your machine, you basically get two things: a compiler as well as an interpreter. Okay. Now what does the interpreter do? The Java interpreter converts the bytecode that is .class to a machine understandable code, and then it interacts with the operating system. Your interpreter is the guy who actually converts your .class to a machine level code and get the instruction executed on the machines. Okay. Next, high performance. Java is a high performance language. What does it mean? Okay. Now Java has a concept of JIT. And we'll talk about this in JVM architecture. When we start exploring JVM architecture, we'll talk about this JIT again. JIT stands for just in time. And what does it say? Once you are done, once you have compiled your Java code, you get a .class file done. After that, whenever I have to call some method, instead of loading everything, I would be able to extract only that method, convert that into a machine level code and execute it. That is where the performance would be great. Okay. Now, for example, think about this. You've written a lot of Java classes. Everything is converted to .class file, compiled, and now that compiled code is basically getting executed. Now see, when you are writing simple program like adding two numbers, find whether a number is prime or not, when you write this kind of code, it always looks simple. But when you actually build a product, okay, the whole project would be lot of lines, right? So the whole project would be very huge. In that case, if let's assume JVM has to load everything on the memory, and if it converts everything into machine learning code first, then the problem would be it would become slow. right? So what JVM has done, JVM has included a small component called just in time. It's a small component which says whatever method I need to access, I have the capability to just extract that method, convert that into a binary and execute it. Okay, so that I don't really have to worry about converting everything into a binary code. Okay, so that's how the Java would be performing very high. Next, the bytecode that you basically generate are highly optimized. Okay, so because bytecodes are not written by us, it is created by your tool itself, right? Your Java itself. Your Java compiler converts a .java file to a .class file. That .class file contains all the bytecode, and that bytecode is highly optimized because it's a product of 25 years now. People have researched a lot. People have built it better over the last 25 years, right? And that's the reason it's very optimized, and that's the reason the JVM would be able to execute them much more faster. Next, multi-threaded. Now, the beauty of Java is it supports multi-threading, and multi-threading is one of the backbone of your Java programming. A lot of, in many places, you need to write some multi-threaded code, wherein you would like to say, I want to do 10 different stuff using this technique, right? And Java allows you to implement multi-threading very, very easily. And we'll be talking about that also in great detail as we move on with the program. So let me give you some highlights about these threads. Now let's take an example. Okay, say you have some file. Let's say you have a file employee.txt. Say you have a file department.txt. Say you have a file salary.txt. And what I want to do is I want to write a Java program which can read the content of this file, this file, this file, and store it on a database, right? So we will be writing a code, a Java program that can read this file, that can read this file, that can read this file, and store this data in a database. And in the database, you'll have definitely 3 tables, right? You have an employee table, you have a department table, and you'll have a salary table. So you'll have 3 tables altogether. Table 1, table 2, table 3. Now, what is the requirement? The requirement is very simple. Your Java program would read employee.txt and would write it here. This is your employee table. Your Java program should read department.txt and should write it here. This is department table. Again, your Java program should read the salary.txt and should write it here, right? Now, what is the best way to do this? Now, as a newbie on Java programming, the best way to do this would be read this file one by one. First, you read the file. First, you read this file, read, push the data to employee, done. Again, repeat the same thing with department. Again, repeat the same thing with salary. But I want to ask you a question here. Are these data dependent on each other? No, because these are all independent files, right? And if you ask me, how do you write it in much more optimal way, right? For example, let's say this file is very big, this file is very big, this file is very big, and it is taking some time to write the data. Let me introduce a little complexity here, okay? Now, maybe my requirement changed a bit. My requirement changed like this. In employee.txt, I have Aadhaar and PAN of a customer, of the employee. I want to call some services to validate if the Aadhaar is valid, if the PAN number exists. Okay, and if valid, then only I'll write the data into the database. Now what happened is, I've added little time here, right? Because calling this Aadhaar and PAN are third-party services, and they may be a little slow. It is possible. Okay, and if I have, let's say, 10 lakh records. If I have 10 lakh records, 1 million records, then the problem would be this would take a lot of time. Okay, and since it is taking a lot of time, your department.txt file, it has to wait, because unless and until you don't complete your employee.txt, you will not be starting writing this thing, and you will not be starting writing the other stuff, right? And that will make your program slow, of course. Now the beauty is you will always claim that my machine, my Mac or my Windows has 8 cores. But the question is, what are you doing with these 8 cores? Right? Why don't you write a multi-threaded program which can do this? Let one core handle this, let another core handle this, let another core handle this. You still have 5 cores to do all the other activities, right? And if you are able to achieve that, then the advantage is your program would be fast. The reason is because one core is actually handling this. The remaining, like one core is handling this, the one core is handling this, right? So since one core is handling this, the other 2 cores can easily push this data here at the same time, simultaneously, right? That is what we call a thread. Now you may say, hey, can I not divide this whole 10 lakh records into probably, see, I have 8 cores, okay? I have total 8 cores, right? One core is taken by this guy, another core is taken by this guy. How much is left? 6 cores. Let's assume 2 core I would like to reserve for for operating system and other services. Can I not use the 4 cores here? You can, okay? And that's what we are going to learn in multi-threading, right? So what I'm trying to tell you is Java has a concept of multi-threading, which you can implement very easily if you understand the language properly. It's very tough if you don't understand it, right? But at the end of the day, it allows you to do multiple tasks in the same program at the same time, right? So the same Java code, when you run, can actually activate 4 or 5 threads. Each thread is doing something, right? For example, when you are working, right, you would basically start your environment and you start writing a code, and at the same time you also listen to the background music, and at the same time you receive your email and whatnot. So don't you think this is all multi-threading things that is actually going behind the scene? Yes, right? The only thing is we don't recognize it, right? Have you ever faced any problem like this? If you want to send a mail, you need to close your music. No, right? So these are all happening internally in terms of threads. Okay, so Java supports implementation of threads very easily, and because of which you can take the advantage of those concepts to make your Java program much more efficient. Okay, next thing, distributed. Now Java can be used to build distributed system. What do you mean by that? So distributed system means what? Few pieces of code are here, few pieces of code are there, few pieces of code are there, and it runs independently, and the task can be aggregated, and that output is your final output. Now, can I call the data engineering tools as a distributed system? Yes, right? The way Hadoop works, the way Spark works, they all actually are distributed, right? So they do the work independently, and finally the output is merged together to get you the final output. And that is the reason why people chose Java or JVM based language to build systems like Hadoop, MapReduce, or Spark and all, right? So I hope you understand how much important this Java is all about, right? So Java is a distributed because it encourages user to create distributed applications. You can have a concept called RMI, remote method invocation, which allows you to call a method which is running on a remote machines. Okay, you can write some socket programming to create a chat applications. When I was in BTech, my final year project was to simulate Yahoo chat. That time Yahoo chat was so much popular. Today I don't know if it is available or not, but those days Yahoo chat were so much available, and I used to spend a lot of time chatting with different people because it was a new juice altogether, right? And then I thought, hey, when I know Java, because as I said, before I went to college, BTech, I was good in Java itself. And when I was in college, I started learning Java in more better way. So I thought, when I know this Java stuff, when I know how to write threads, how do you write a socket programming and all, why not create a project on your own rather than going to the institute and buying it from them? So I was the guy who created the project on my own. I took 2 machines, a friend's machine, my machine, coded everything on my machine, changed the IP address, and I demonstrated that in front of the invigilator that this is how I basically created a project wherein people can chat with each other. Okay, and the means the external, he actually asked me a question, what is the future scope of your project? And I was clueless. The reason is because you cannot build a company like that, right? I said, I did it for my final year. I don't know whether I can take it to the next level or not. Okay. Now, let's talk about one more important thing that you should know, the JDK and JRE. Okay. So when we talk about Java, you basically will encounter these two words very, very frequently, JDK and JRE. Let's understand what exactly it is. So now we are going to talk about JDK and JRE. Okay. So remember, JDK and JRE, JDK stands for Java Development Toolkit or Java Development Kit. Development, okay, and JRE stands for Java Runtime Environment. Okay, now these words are sufficient enough for you to understand at a high level what exactly it is. Okay, so JDK is a development kit, which means it contains the set of libraries or tools or applications that can help you to build your code. For example, what do you need, guys, to write a Java program? Number one, you need a notepad probably. Okay, let's talk from day one. Few examples we will do it on notepad, few examples. Then we will move to Eclipse. Then we will move to IntelliJ. And then we'll start building everything in IntelliJ itself. Okay, so to build a Java program, to write your very first Java program, what you need? You need an editor. For example, Notepad. Okay, Notepad you will get from Windows itself, or you can install Notepad++ or anything. And then you write the program and you save this as .java file, right? Done. So you'll say hello world.java. You're done. You'll write the program and you'll save it as a Java file. Done. After that, what you need? You need to compile it. Is not it? Because that's the development. The developer is supposed to compile the code. Okay. So you have to compile this to .class file. To compile, what do you need, guys? Compiler. And how do you compile the code in Java? You use a tool called javac. Javac is a command. We will see that javac is a command that can help you to compile a .java file to a .class file. So this is your compiler. Okay. So let's assume you have written a program called hello world.java. The step to execute this would be you will say java c compile. C stands for compile. Okay. Hello world.java. And when you hit enter, what does it give you? It gives you a .class file. It gives you hello world.class. The output of this command is this hello world.class. After that, if you want to execute the program, you will say Java hello world. That's it. You'll not write here .java. Okay. And here it is just Java. So Java C stands for compile and just Java stands for execute. Okay. This means execute. So if you see, I need a Java C to compile my code, but I need only Java to execute my code. Okay. Now, when we are working as a developer, we basically install JDK. Okay. And when you install JDK, remember one thing, JDK also comes with JRE. So when you install JDK, what you get is you get JDK plus JRE, because you are a developer, and if you write a code and if you cannot even compile and see the output, that does not make any sense, right? So when you install JDK, you get JDK, you also get JRE. And what is this JRE? We'll talk about it. Okay. So what do you have in this JDK, guys? You get Java C tool, you get Java tool, along with a lot of things like Java P and so on. We'll look into those folders once we install Java. But when you install JDK, what you get is you get Java C, Java P, and everything. Okay, done. Now let's talk about what is a JRE. Okay, so once you build the program, what you got is you got a class file. Now this class file you would like to execute it on a server, right? See, this MacBook is my developer machine, right? And I built a project, done, and I probably created a jar file or war file, whatever. And now I would like to deploy this code into a server. In that server, do I need a JDK, guys? Do I need a development kit in the server? No, right? Because you are not going to compile it. The compilation should happen on your machine altogether. Okay. So in that case, all you need is only JRE. So you can download only JRE also from the website, okay, from the Oracle website. And when you download JRE, what you get is you get Java command. Okay, so let me write. If you download only JRE, you get a Java command, but you don't get a 𝗪𝗃 command. The reason is the 𝗪𝗃 is for compilation. Okay, and when you install JRE, you're not supposed to get 𝗪𝗃. You're supposed to get only Java. Okay, which means for the developer you need JDK, and for the server you actually need only JRE. Okay, so JDK gives you a set of tools, JRE gives you a set of tools. JDK gives you the set of tools which can help you to write the code, compile the code, and execute the code, whereas JRE gives you all the tools that is used only to execute the code. So I hope you're clear with JDK and JRE now. Like, just Google it out, JRE download, okay, and then it will take you to some link. Just go to some authentic link wherein you can find a way to download only JRE. So let's check this out. Okay, I just downloaded for Windows, okay, just to see what exactly it is. This is only JRE. See this? It is only JRE that contains only set of libraries or tools that can help you to run the program but not build, right? So the size of JDK and JRE are different. The size of JDK is of course bigger than the size of JRE. Your JRE has only the set of tools which can help you to only execute the program.